Okay, let's draw our first puzzle cube part in Inventor. And I'm going to draw this part. It's 1, 2, 3 cubes on the bottom and 2 cubes going up vertically from that. And there's a couple ways I can approach this. One is I can add material or do some additive modeling. Every time we draw an Inventor, we're creating a solid model. So we call this modeling. We can do some additive modeling by building up with several extrusions. We could also do subtractive modeling, where we would take a hunk of wood, this is a wood puzzle cube, and I would remove material to make the shape that I want. Third way is we could make an assembly of just cubes, kind of in the way that you're going to be building your parts. But because when we're done our part, it's one solid piece, building it up in cubes gives us a less realistic example of the part itself. Even though it matches the way you're going to build it, we want to think of these puzzle cube parts as an entire part, not an assembly of cubes necessarily. But I'm going to show you all three ways. We're going to do some additive modeling, some subtractive modeling, and then assembly modeling. So the first thing I'm going to do is you're going to open up Inventor, and we're going to create a new part file. You can also click on New and open up the dialog. We're still going to open up a standard.ipt file. So remember, our parts come first. We then assemble our parts in an assembly. We then create a drawing of the part or the assembly on a title block. And we could create a presentation, which would be an exploded view for an assembly. But I'm going to start up a new standard part. The templates are all set up for feet and inches, so you don't have to worry about using metric or not metric. And I'm going to go back and forth and reference the part that's already completed as we draw this, because the front view for this part is going to look like this. It's descriptive of the shape in that it shows its full height, it shows the L shape, and it won't have any hidden lines. And that's something that's important to think about when you pick your front view. And I often use my front view as the starting point for my sketches because I see an L shape. It's 2 cubes wide, so it's 1.5 inches in this direction. It's 3 cubes high, so it's 2.25 inches in this direction for the height. And the depth isn't something I'm going to worry about necessarily because, well, a sketch is just two-dimensional, and all I'm going to see is an L shape. So this is what I'm going to use for my first sketch. So I go back to my part. I start a 2D sketch. And my front face is parallel to this XY plane. And again, it doesn't really matter what plane I pick, but for consistency with the view cube, because I'm starting from my front view, I'm just going to pick the XY plane for my starting sketch. And I'm going to sketch not with exact reference to dimension, but I'm looking for shape first, dimensions next. So I'm going to start at the origin to anchor by clicking down. I'm going to use the line tool, not a rectangle tool, because I'm going to sketch a series of line segments to make my part. So I'm going to start on the origin. When it's green, that means it's locked in. You can also see that little dialog box in the bottom right corner of the crosshairs here. It says that I'm at 0, 0, which is the origin. And as I move a little bit, it doesn't move. It's telling me I'm locked in. So the green dot's visual, but if you're a numbers person, you can look at that dialog box that pops up. I'm going to click on the origin. I'm going to come over approximately 1.5 inches. Now I'm zoomed out, not quite enough, so I'll zoom out a little bit more. And there we go. I can go just about 1.5 inches. Doesn't matter. Doesn't have to be exact. Now, some of the things we see is that as I draw, Inventor predicts for you. It's thinking that, you know what? There's a good chance that this person that's drawing might want a right angle. And sure enough, you can see that there's a little perpendicular constraint. As I move up and down, you can see it move with the mouse. It also tells me that I'm 90 degrees to the previous line, which is a right angle. So I'm going to let it predict some of these geometric constraints. I do, in fact, want this to be perpendicular, so I'm going to hover along that line and let it keep me at 90 degrees. I'm going to come up about 3/4 inch because we're 1 cube high. That's close enough, 3/4. I'm going to come back in and you're going to see a couple of things happen. One, as I hover over the oops, I clicked accidentally. I'll undo that click. Go back to the line tool, and you can always resume lines by coming back again. The green dot shows that you're connected to an existing point. So I click down. As I hover over the midpoint of that first segment, you can see a little vertical dashed line appear, and that's thinking that it's predicting that, hey, maybe this person wants to have this segment end at the midpoint of the previous. And in fact, I do, because the bottom line was 2 cubes wide. I'm only drawing 1 cube now. So I'm going to let it predict that, in fact, I do want it to be half as long as the segment I drew first. Click down there. Now again, I'm going to zoom back out and I'm going to go 2 more cubes up, so another 1.5 inches. It's predicting perpendicular. I'm going to let it go that way because that's what I want. Not exactly 1.5 inches, but pretty close. I'll click down one more line. As I come back over, it's again predicting perpendicular. That's what I want. As I get back to the vertical axis here, it's trying to lock in on that to be directly above. And you can see I move my crosshairs a little bit and the point doesn't move. It still stays at 0.48, and that's what I want. I want to be above the origin, so I let it predict that. And then finally, when I come back, I close my loop. Closed loops are necessary, which means that all my endpoints connect. Back at the origin and click down. I am done. My L shape is complete, so I'm going to right-click and cancel and be done with the line drawing tool. Now I need 4 more dimensions, which means that I'm not fully constrained. I can drag these green lines anywhere I want. Now that was a bad idea, so I'll undo that dragging. But I need to get rid of the green and go all purple to get fully constrained. So I'm going to start adding some dimensional constraints. I am going to say that this line down here is 1.5 inches because it's 2 cubes. I could say that this is also going to be 1.5 inches because it's 2 cubes, but there's another tool that Inventor allows us to do. Whenever we know that 2 line segments are going to have the same length, instead of applying a dimensional constraint, I can come up to this constraint panel up on the sketch ribbon, because I'm using the sketch tab. Got that phone call. It was a wrong number, believe it or not. So I am going to go up to the constraint panel. I'm going to use one of these geometric constraints. And what I'm going to use is an equal constraint. If you're not sure what these icons do, you can always hover over them and specific help will pop up with information about that icon. And an equal constraint, as this little help tells me, says I can pick circles and arcs to be the same radius and lines to be the same length. Well, guess what? I want 2 lines to be the same length. This seems to be the tool I want. So I'll click on the equal constraint. I'm going to say that this line segment has an equal length to this line segment. And now, no matter what dimension I put down here, this segment will have the exact same dimension. And guess what? This segment is 1 cube long. This segment is 1 cube long. So while I'm at it, I'm going to say that this segment is the same length as this segment. And then I'm going to right-click and cancel to get out of the equal constraint. And you always know that you're in a tool, 1, because that icon will be highlighted, and 2, next to your mouse pointer, there will be a little icon indicating what tool you're using. Now, all I told Inventor was this and this have the same length, but I didn't tell it what this length was. I'm going to show you something amazing, just how smart this program is. It's way smarter than I am. If I click on a dimensional constraint and I tell Inventor that this line is going to have a height of 2.25 inches, I'm done. I'm fully constrained with only 2 dimensional constraints, because when I told Inventor that this line was the same length as this line, it knew it was 1.5 inches. And because I said from here to here is a total of 2.25, the only length available for this is 3/4 of an inch, or 0.75 inches. So our goal, to be flexible, is to have as few dimensional constraints as possible and as many of these geometric constraints as possible. I could have very easily put dimensional constraints for every segment, or as many as needed for Inventor to know what the full dimensions are, and not worried about any geometric constraints. But it makes us much more flexible, because what if I decide, you know what, this is actually going to be 2 inches instead? It will automatically scale the rest of the line segments based on the proportions and the geometric constraints I put in there. So using few dimensional constraints and many geometric constraints really makes us flexible when we make changes to our parts in the future. However, this needs to be 2.25 inches for 3 blocks high, and we're done. I'm going to finish my sketch. So now I got my front view done as far as a 2D view goes, an orthographic projection. However, I know that, let's go to my isometric view, from my front to the back, which would define the depth of my part, that my depth is 2 blocks. But this L shape only describes a 1 block depth. So I'm going to now make my extrusion, first part of my extrusion, and I'm going to extrude this closed profile. Because there's only one closed profile, it automatically picks it for me. And I know I have a profile chosen, 1, because I can see it here, but 2, my arrow up here next to profile is white, which means it already has information. I don't want to extrude it 1 inch, I want to extrude it 3/4 of an inch. And there we go, we have the back part of our cube, this L shape. The only thing I need to add now is I have this additional cube projecting from the front view, a single cube, 3/4 of an inch deep, 3/4 of an inch wide, 3/4 of an inch high. I'm going to come back to my part and I'm going to draw a new sketch. So all we need for sketches are planes or surfaces of objects. This is not a plane because it's a small surface, but there is a plane that would contain the small surface. So in fact, this surface is merely a representation of a portion of a plane. I can use that to sketch. I'm going to click Start 2D Sketch. I'm going to click on this face of the sketch or of the part to sketch on it. And I'm going to now use the rectangle tool because I know I'm just drawing a cube. I don't need an L shape. I can go to rectangle. I'm going to use the 2-point rectangle, meaning I'm going to pick one vertex and the opposite vertex and let that define the rectangle. So click on rectangle, and I'm going to use the existing geometry to guide me. Excuse me. I'm going to start at the origin. I could start anywhere I want, but I'm going to pick the origin just because I know that that's an anchor point for me. And it's connecting back to the existing geometry, being these edges and corners of that part. So if I click on the origin and lock in, and then also click up here on the intersection of these two segments and lock in, you see that those dimensions are both 0.75 inches exactly. Well, that's because we drew our original sketch with 0.75 inch dimensions. And by locking into that, we don't even need to put any dimensional constraints in here. We are, let me right click and cancel. We are fully constrained only using geometric constraints. We did a lock constraint or coincident constraint is what they call it, where this point was on the existing point and this point was on this existing point, and it locked it in as 3/4 of an inch in both directions for us. The nice thing about that is if I go back to my original sketch and make dimensional changes, this sketch will update automatically. So again, few dimensional constraints, many geometric constraints is our goal. That's all I need for my sketch. Finish my sketch, I'm done. Now this time when I click extrude, I again only have one closed loop, so it predicts that. It goes to the previous extrusion distance that I used, 0.75. That's perfect, that's what I want. I don't need to do any more work. I just click OK, and there we go. I have a part. If I want to make it red, I can come up here, and instead of default color, I can pull down to, how about light red, and it will change the entire part for me. So that's it. That's your first puzzle part built with additive modeling. Next, we'll come back and we'll do some subtractive modeling. Good luck.